It's one small step for man, one giant leap for mankind.
50 years ago, Neil Armstrong took his first steps on the moon. The Apollo 11 lunar landing was a historic event of astronomical magnitude for all of humanity. But it didn't just put the US ahead in the space race. It was the catalyst for many more groundbreaking space missions. In the past decades, humans have managed to photograph solar systems light years away, calculate the size of black holes, and send rovers to neighboring planets and asteroids, allowing us to understand, at a minuscule scale, the vastness of our universe. Now, companies like SpaceX, Blue Origin, and Virgin Galactic are pushing the envelope even further, with dreams of creating human space colonies. But it took many years and many missions to get us where we are today. You're watching Explore Mode, and today we're diving into 3 space missions that changed and shaped the way we see space today. The Pillars of Creation, the Helix Nebula, the Tadpole Galaxy. These are star formations light years away, and they're impossible to spot with the naked eye until they were made visible by this 29-year-old telescope. This is the Hubble telescope, and since its launch in 1990, it has been coasting above Earth's atmosphere, snapping pictures of planets, stars, and galaxies far away. This 43.5 feet long space-based telescope took decades to engineer. It orbits Earth at an altitude of about 350 miles at 17,000 miles per hour, completing a single orbit in roughly 95 minutes. But how exactly does the Hubble telescope take these fascinating pictures? The Hubble has 2 mirrors inside its body, a concave primary mirror and a smaller convex secondary mirror. Light from space enters the telescope and reflects off of these mirrors. The light is then interpreted by an array of instruments aboard the telescope. Many of these light frequencies are invisible to the human eye. The first photo the Hubble telescope sent back to Earth was of a binary star called HD 96755, located 1,300 light-years away. The picture is blurry in contrast to later images by the Hubble, but that's because it's a result of the telescope's first light test, meaning that this image represents the first time the Hubble had successfully captured light in space. Although the resulting images we see now are bursting with color, the actual photos the Hubble captures don't come back colorized. They start off as black and white images. The colorizing process works like this. The Hubble takes several images of the same object using different broadband filters, red, green, and blue. Once they're merged, they can be rendered into fully colorized images that make sense to our eyes. Gases in space like these are colorized using narrowband filters that isolate the colors of elements such as hydrogen, sulfur, and oxygen. Now, gases don't really look like bursts of purple, red, and orange. Scientists assign different colors to each element. This makes it easier for the human eye to observe and study chemical reactions in space. The Hubble telescope was named after this guy, Edwin Powell Hubble. Hubble's research helped demonstrate that our universe is constantly expanding, and he developed a classification system for galaxies that is still used today. But years before the Hubble telescope sent back these images of our neighboring planets, there were 2 Voyagers that set off into the darkness of the universe in humanity's name, literally carrying our legacy with them.
Oiknis poteste chairete, eirenikos pros philos elelithamen philoi.
That recording is in Greek, and it's one of 55 multilingual greetings directed towards extraterrestrial life that are engraved in the Golden Record. This record not only carries human greetings, it contains images of Earth, its animals, and its people, as well as its sounds, such as human footsteps, music, erupting volcanoes, and thunder. It's a time capsule of humanity. A time capsule that travels aboard the Voyager 1 and Voyager 2 spacecraft. These 2 probes left Earth from Cape Canaveral in 1977, with no intention of heading back home. See, in the late 70s and 80s, Jupiter, Saturn, Uranus, and Neptune were aligned in such a way that they would allow the spacecrafts to use Jupiter's gravitational pull as a slingshot and send them on their way to Uranus and Neptune. This geometric alignment only happens once every 175 years. So they had to make the most of it. Their main mission was to gather and send back as much information of the 4 planets in the outer solar system. And so they did. The Voyagers were the first to send back clear images of the gas giants. Never before had humans seen such clear photos of Saturn's rings, Jupiter's Great Red Spot, the rings of Uranus, and Neptune's Great Dark Spot. Together, the spacecraft helped discover 3 new moons in Jupiter, 4 new moons in Saturn, 11 new moons in Uranus, and 6 new moons in Neptune. It's been over 40 years since the Voyagers left Earth, and by now they have long sailed out of our solar system, becoming the first human-made probes to enter interstellar space. They continue to travel billions of miles away from their home planet, and continue to send back data on the interstellar environment surrounding them on a daily basis. The last series of photos the Voyager 1 took are portraits of our solar system. These are the only existing images humankind has of our space neighborhood, and they were taken just as Voyager 1 was approaching interstellar space. It may seem like nothing at a first glance, but if we look closely, we can find home. It takes 19 hours for Voyager 1's messages to reach NASA's Deep Space Network. The data from Voyager 2 takes 16 hours. Once NASA's collection of antennae gather signals from these 2 probes, they're sent to scientists who then interpret them and convert them into readable data. The spacecraft are powered by radioisotope thermoelectric generators, but many of their components have slowly shut down one by one. One day, these 2 explorers will go completely silent. But even then, should anyone find the golden records attached to them, they will speak for us and carry on our legacy. But we don't have to go to the ends of our solar system to find traces of human civilization in space. In fact, there are 6 humans orbiting above us right now, waking up inside the International Space Station. Just 400 kilometers above Earth orbits the International Space Station, a home away from home for humans studying our universe. The ISS is a thing of science fiction. There have been other smaller stations before it, but none quite like it. In fact, it's the largest single structure humans ever put into space. Its story starts in 1984, when then-President Ronald Reagan asked NASA to make it a reality within just 10 years. 5 other space agencies worked along NASA to bring the ISS to life, including Europe's ESA, Russia's Roscosmos, Canada's CSA, and Japan's JAXA. The result of their work was a space station/orbiting research facility the size of a football field, including the end zones, completing a full orbit around Earth about every 90 minutes, meaning that in a single day, astronauts living inside it see 16 sunrises and sunsets. Retired NASA astronaut Peggy Whitson has spent more time in space than any other American, 665 days to be exact. During her time at NASA, she became the first female commander of the ISS, and on top of that, she is the woman with the most spacewalks, having done 10 spacewalks that amount to 60 hours and 21 minutes in space. The ISS has 6 sleeping areas, 2 bathrooms, a gym, and a 360-degree view bay window that give those aboard a breathtaking view of home. The ISS gym has a bicycle, a treadmill, and a weightlifting machine called ARED, or Advanced Resistive Exercise Device. A gym may seem like an unnecessary commodity in space, but it's actually essential for the astronauts' health. The human body is sadly not designed to float around in 0G. Our muscles and bones need gravity in order to not deteriorate, so astronauts have a strict schedule of 2.5 hours of exercise per day, 6 days a week, in order to not suffer bone and muscle loss. But what do astronauts do up there? Apart from carrying out maintenance and repairs to the stations, they conduct experiments in biology, biotechnology, physical science, astronomy, meteorology, and human health. For example, for one experiment, researchers aboard the ISS are cultivating plants in space to understand the effects gravity would have on astroculture. That's agriculture in space. So far, 236 people from 18 countries have been to the International Space Station, which is expected to be funded until 2024, although many hope that can be extended until 2028. But whether or not we're aboard a flying space laboratory or sending probes with recordings of thunder, humans will always find a way to know more about our universe and connect with whatever may be out there. Thanks for watching Explore Mode. If you liked this video, hit the thumbs up button. If you want to explore even more with us, make sure to hit the subscribe and bell buttons so you get a notification whenever we upload a new episode. See you next week, and in the meantime, keep your Explore Mode on.